There, welcome to the another video of our course, that is software engineering. Here in this video, we are going to discuss about basic of data flow diagram. So, without wasting much of time, let's start our discussion. So, this data flow diagram is one of the modeling technique especially used in function design. So, before drawing the DFD diagram, first we need to do the structure analysis. So the structure analysis is usually carried out to the top-down decomposition of set of high-level functions depict in problem description and to represent them graphically. So the first step doing the functional before drawing the DFD diagram, first we need to identify the different types of functions that system may have. Then we need to represent this function in graphical or in hierarchical order. So this structure analysis technique is based on the following essential underlying principles. So first, in this structure analysis, first we need to do the top-down decomposition, or it follow the top-down decomposition approach, which means first we need to identify the high-level function, then we need to subsequently find the low-level function associated with that particular functions. And it also follow the divide and conquer principle, which means first we need to identify the high level function. Further, these functions can divide into sub function or similar type of functions. For example, here we have first high level function a. This high level function further consists of three sub functions, that is b, c and d. Further, this b function have three more functions, that is e, f and j. Similarly, this function d further have three functions, that is h, I, j. So this is how the structure analysis arrange the function in hierarchical order, or we can represent this function in top-down decomposition. After identifying all the functions, then we need to represent this function graphically using data flow diagram. So in simple words, first we need to do the structure analysis, then we need to identify the different types of functions that system may have, and these functions have further sub functions. So we need to identify all those functions that system may have. After identifying the function, then we can draw our data flow diagram. So the data flow diagram is also known as bubble chart. Sometimes data flow diagram is also known as bubble chart. So this data flow diagram and bubble chart are same. So this data flow is the hierarchical graphical model of system that shows the functions that system performs and the data interchange among function. So this DFD diagram shows the different types of a function system may have and what are the data exchange between these functions. So as you all know, each function consumes some input data and produce some output data by processing those data. And this DFD model represents system in terms of function and the data flow among this function or data flow among different entity. So this data flow diagram usually used to show the flow of data between different processes or functions. And also we have these 5 symbols to represent the, or we can using this 5 symbol we can draw our DFD diagram. So this first type of symbol, this is rectangle symbol, which is used to represent external entity, and this circle symbol represent the process or function, and these symbols used to represent the output, and this arrow symbol represent the flow of data or data flow arrow, from where, from which process to which process the data are flowing. To show this symbol, to show the flow of data between process, we can use this arrow symbol. And this is used to represent the data store or logical data storage. So this is the 5 symbols that we can use to draw our DFD diagram. So we are going to see each symbols in detail. So the first type of symbol is external entity symbol. So this external entity symbol is represented by rectangle. So these external entities are either user or the some external system. So this external entity is used to represent the user of the system or some external entity that may use the system. This external entity produce some input to the system or consume some output from the system. So for example, consider we have a library management system, and one of the user of library management system is the librarian. So we can represent this librarian as this rectangular box, and we need to write the name of that external entity. Here in this library management system, our external entity is the librarian, and we can represent the librarian as this rectangular box, and inside this rectangular box we need to write the name of that external entity. So the external entities are either users or the some external entities or some external software which can use the system. So this is how we can represent the external entity using rectangular box. Now second type of symbol is functional symbol, or this symbol also called a process, bubble or transformation. So this functional symbol, sometimes we call it as process or bubbles or transformation. So this process, bubbles and transformation is same as the functional symbol. So this can be represented by circle. So this is how we can represent the function in a DFD diagram. So we used to represent function using this circle, and the function represent some processing activity. So these functions, so the functions in a system are capable of processing some data and can generate the some input. For example, add is a function which is capable. For example, we have a calculator, and in calculator we have add is a function which is capable of taking the input from the users and process and capable of processing those input and generate the output. So the functions can be represent some processing activities in a system, and the name of the function must be verb. So when we are giving a name to any function in DFD, we must use verb, that is action related word. For example, in our library management system, search book is a function which is used to search the book in our system. So this search book is one of the function of our library management system, and we can represent this search function as this using this circle, and inside this circle we need to write the name of that function, and name of the function must be verb, that is action related word. So this is how we can represent process or function in our DFD diagram. Now another type of symbol, that is data flow symbol. So this data flow symbol is represented by arrow, this type of arrow, and it is used to represent the flow of data from process to process or from process to entity. So when we used to represent, or when we need to represent the data flow from one process to another process, then we can use this arrow, or we can also use to represent the flow of data between different entities. So the name of the data must be written on the top of arrow. So which data is flowing from one entity to another entity, we need to represent using name. So this is how we can represent the flow of data, and this is the name of data which is flow from one entity to another entity. So this is the data flow symbol which is used to represent the flow of data between different entities of a system. So let's take an example. So here we have a librarian, that is external entity of our system, which used our system, which will use our system. And suppose we have a function that is search book, and this arrow represents the flow of data from library to search book, this arrow. And what type of data? This is the book ID. So the library is input, library is use this book ID to search the book, or this book ID is the input to this search function. This is search book, and this search book produce some output, and the flow is represented using this arrow, and the data is the book details. So this is how we can represent the flow of data between one entity to another entity. Similarly, we can use to represent the flow of data between process to process. For example, we have one process. So this is P1. Suppose consider this is the name, and we can use the flow of data like this. So process to process we can use to represent like this P2. So this is how we need to write the name of data. So this is how we can represent the flow of data between process to process. We are going to see in our next slide how to represent the flow of data between processes. So this is how we can use the data flow arrow to represent the flow of data between entity or process. So the next type of symbols that we can use in our DFD is data store. So this is represented by logical file. This is how we can represent the data store. So data store is the logical file where we can store our data. So this logical file can be data structure or physical disk. So to represent the data structure or physical disk or some storage device in our DFD, we can use this line, and inside this line we need to write the name of that data store. So here we have one data store, that is book details. So data store means data store is the file or the data structure or the physical disk that our system may use to store data. So this is how we can represent the data store, and each data store is connected to process by the data flow arrow. So these data store must be connected to the process or function which is used, the function which use this data store. So for example, let's see another example where we are going to see how to draw data store. So consider this is our search book is a function, and this is another function, that is enter book details. So we have a data store. Let's consider this is our database. So this enter book function is used to enter the detail of the book. So we can say that from this enter book details is a function which is used to store the book details into our book database, and this is the search book functions which used this data store to search the book. So this is how we can represent the data store, or this is how we can represent the flow of data between process to data store or from data store to process. So here in this example we have two functions, that is enter book detail, which is used to enter the book detail into our database, that is our book, and this search book is used to fetch the detail of book from database. So here we don't need to write any name, because all the data available in this book can be used by this search book. So we don't need to write the name of data in this arrow. So this is how we can use the data store, or this is how we can represent the store data store and the flow of data between process and data store. So another type of symbol is output symbol. This is represented by parallelogram, and it is used to show the output produced by the system. We can use either parallelogram or this type of symbols to represent the data output. So data output. So these are the 5 symbols that we can use to draw our DFD. So in our upcoming video, we are going to see how to draw DFD diagram. So before concluding this video, uh, I'm going to discuss 2 important concepts, that is synchronous process and asynchronous process. So here this process is an asynchronous process. Why? Because first this process is entering the detail into this data store, then only this process is fetching the data from the data store. So this is a synchronous process, which means first this process entered the detail into the data store, then only the process is fetching the data from that data store. So the speed of two processes is not same, so that this type of process is known as a synchronous process. So another type of process is synchronous process, where the output of one function is treated as the input of another function, so that the speed of two processes must be same. So this type of process is known as synchronous process. So we have two type of process: a synchronous process where we use the data store to store the data, and those stored data is used by another process, so it is a synchronous process. And another type is synchronous, where the input of first process is used as the output by the output of first process is used as the input for another process. So speed of two processes is same, and this type of process is known as synchronous process. So this is all about for today's lecture. From our next lecture, we are going to see how to draw DFD diagram in detail. Thank you.